Good morning, everyone. Distinguished guests, scholars, experts, a very warm welcome to the SERB-sponsored 2 days National Symposia on the profound theme of application of geospatial science for natural resource management. As we stand at the intersection of technology and environmental stewardship, it is our commitment to explore the transformative potential of geospatial science in managing our precious natural resources. But before we proceed further, we would like to express our sincere gratitude to SERB India for sponsoring this symposia, Geography Department, and Midnapore City College, whose unwavering commitment has made this symposia possible.
We are honored to have with us today some of the brightest minds and visionaries in the field of geospatial science and natural resource management. Their insights and experience will enrich our understanding and pave the way for innovative solutions. We are also tremendously honored to have with us Professor Sushant Kumar Chakraborty, Honorable Vice Chancellor of Vidyasagar University, here today in the symposia. We will inaugurate this occasion with a musical performance by our students. Let this performance be a symbol of inspiration and harmony as we embark on this new journey together. Please welcome our students as they take us on a musical journey with the iconic song Aguner Poroshmoni.
A heartfelt thank you to our students for such a mesmerizing performance.
Now we would like to request Dr. Pradeep Ghosh, Honorable Director, Midnapore City College, to come on the stage. At the same time, we are requesting our Honorable Vice Chancellor of Vidyasagar University, Professor Sushant Kumar Chakraborty, to come on the stage as well. Our Honorable Director Sir now will be felicitating Professor Sushant Kumar Chakraborty, Honorable Vice Chancellor of Vidyasagar University. A big round of applause, everybody. An outstanding moment for our college.
It is an immense honor for us to have with us today on the dais Honorable Vice Chancellor of Vidyasagar University, Professor Sushant Kumar Chakraborty, sir. Sir, truly your presence has graced us and also graced this moment.
Now we are requesting our students to felicitate our Director Sir. A big round of applause. Now we would like to welcome Dr. Sudipta Chakraborty, Principal, Midnapore City College, to come on the stage. Again, I would like to request our students to felicitate him.
Now we would like to welcome Dr. Kuntal Ghosh, Vice Principal of Midnapore City College, to kindly come on the stage. I would like to invite our students to felicitate our Vice Principal. Our students are welcoming with a bouquet of flower and some token of appreciation our Vice Principal of Midnapore City College, Dr. Kuntal Ghosh. Now, we would like to call up on stage Professor Nirmal Kumar Sarkar, Emeritus Professor of Midnapore City College. I would like to invite our students to felicitate Professor Nirmal Kumar Sarkar, sir. A huge round of applause. Now, it would be an honor to welcome Professor Pabitra Bonik from Indian Statistical Institute, Kolkata, to kindly come on the stage. I would like to request our principal, Dr. Sudipta Chakraborty, sir of Midnapore City College, to kindly felicitate him with a bouquet of flower and some token of appreciations. Our principal, sir, is felicitating our keynote speaker for this inaugural session, Professor Pabitra Bonik from ISI, Kolkata. Thank you, sir.
Now I would like to welcome Dr. Kakoli Banerjee, Assistant Professor and Founding Head, Department of Biodiversity and Conservation of Natural Resource, Central University of Orissa on the stage. I would like to request Dr. Kuntal Ghosh, Vice Principal, Midnapore City College, to felicitate her. A big round of applause, everybody. Now we would like to welcome Dr. Kiran Jalim, Assistant Professor, Department of Geoinformatics, Central University of Jharkhand, to come on the stage. Again, he will be felicitated by Dr. Kuntal Ghosh, our Vice Principal, sir. Once again, thank you to our esteemed guests for gracing us with their presence. Your achievements and presence have made this gathering truly special.
We will also welcome our convener of the Symposia with a bouquet of flower and some warm appreciations. I would like to invite our students to kindly felicitate the convener of the Symposia, Dr. Kartik Bera. Thank you, everyone. So as we commence, this gathering, we are privileged to partake in a time-honored tradition, that is the lamp lighting ceremony, symbolizing knowledge, unity, and commitment. So I'd like to invite Honorable Vice Chancellor of Vidyasagar University, Professor Sushant Kumar Chakraborty, sir, and also the Director of Midnapore City College, Pradeep Ghosh, sir, to kindly do the honor of participating in the lamp lighting ceremony. I would also like to invite our esteemed guests, Principal, Vice Principal, sir, and our dignitaries to kindly come forward for the auspicious lamp lighting ceremony.
Asato ma sadgamaya tamasho ma jyotirgamaya mrityorma amritangamaya Om Shanti Shanti Shanti.
Now, today is also World Soil Day. So I'd like to invite our Honorable Vice Chancellor, Professor Sushant Kumar Chakraborty, sir, to do the honor of watering the plant ceremony, and also our Director, Pradeep Ghosh, sir, because watering the plant symbolizes our commitment to environmental stewardship, community support, and the growth of positive change. May this ceremony symbolizes our commitment towards promotion of environmental stewardship and also protection of the natural resources. Thank you, sir. Once again, thank you to our esteemed guests, dignitaries. Please, sir, kindly take your positions. We will now unveil the abstract book. So it would be an honor for us if you do the honor, sir. So before we proceed further, I would also like to request our dignitaries to kindly unveil the abstract book of this Symposia. It's a tremendous moment for us. We express our deepest gratitude to all the contributors who have enriched this book with their intellectual contributions. So it's a tremendous moment as now we are unveiling and presenting the abstract book of this Symposia. Thank you, sir, for doing the honor.
Now I would like to request. It is my sincere pleasure to request our Honorable Vice Chancellor, Sir, Professor Sushanta Kumar Chakraborty, to grace us with his presence on the stage and deliver the inaugural address for the symposium.
Good morning to everybody. I am really delighted to be present here on this occasion of a national symposium on application of the geospatial science for natural resource management. Anyway, I am very happy, and again I mention that I am indeed delighted. In order to not only inaugurate this August gathering, but to interact with some faculties, officials, students, distinguished personalities coming over here from different corners of India, to make this scientific meet very successful. The organizer has identified an important topic for this seminar. And this seminar doesn't mean only to exchange our deliberation based on our research findings and knowledge base, etc., etc. But I think the objective of the seminar is to promote some sort of confidence in the mind of our young minds, the future generation of India, on some recently developed subject base. You know very well that we have right now stepped into the world of the interdisciplinary research. So interdisciplinary research is the password everywhere, not only in India and across the globe. Because if you want to address any problem of the world, whether it is in the field of environment or in the field of the healthcare system or in the field of any kind of political, social aspects anywhere, this interdisciplinary approach is the prerequisite to understand not only the problem, to do something to overcome those problems in a fruitful way. And one important terminology has recently been emerged in the world of the knowledge, that is the sustainable way. So the thing is that the organizer, what I have already requested, that they have identified and they have named the seminar in the name of application of the geospatial science for natural resource management. Two important keywords are there. One is the geospatial science and another is the natural resource management. I think my young beloved students know very well what does it mean by nature and natural resources. So any resource which cause the benefit for the human being can be treated as the resource. Any commodities from the nature, those things will constitute the natural resources. Again I repeat, so any commodities which you can harvest based on our knowledge base or research activities, etc., in order to render benefit to the human being should be treated as the natural resource. I think you understand my point. আমরা পৃথিবীর যে কোনো কমোডিটি আমরা যদি আমাদের লব্ধ জ্ঞান বা গবেষণার মাধ্যমে নেচার থেকে প্রপারলি এক্সট্রাক্ট করতে পারি, প্রপারলি মিনস নট ফর দ্য শর্ট টার্ম বেনিফিট বাট ফর দ্য লং টার্ম মিনস in a sustainable way. আমাদের sustainable way, if we can harvest all those resources for the benefit of the nature, that should be treated as the natural resources. And that includes two important categories. One is the living and another is the non-living. You know, so many mining resources are there. India is endowed with all those mining resources which are instrumental to promote proper economic development of our country in one hand. So far as the biological resources are concerned, I am very proud to say, আমি মনে করি তোমরাও সবাই জানো, না জানলেও মাথায় রাখবে যে ভারতবর্ষ পৃথিবীর প্রায় 250টা দেশের মধ্যে একটা, কিন্তু ভারতবর্ষ so far as its performance is concerned, it ranks sometimes 180, 170 or something like that. So far as is in sports activity or in any kind of economic development, etc., etc. I do not like to elaborate all those things in details. But the thing is that so far as the resource base is concerned, especially the biological resource, you know, out of 18 megadiversity country, India ranks around 10 to 11. That means it is within 18 countries. So India is endowed with a wonderful biological resources in the form of the biodiversity. And the biodiversity also varies from place to place. And I do not also like to elaborate all those things in details about the different T10 bits of the biodiversity. You know very well, it starts from the gene and ends to the ecosystem. And this ecosystem also varies from one part of the India to other part based on these agroclimatic factors. So we are having a Sundarbans. I think Kakuli madam is here. I just have a glance over the topic. He is going to say you something about the Sundarban uniqueness, etc., etc. Another person from the Jharkhand is there. He will tell you something about the mining resource possibility potential of that particular locality. If anybody from the desert, he can elaborate the concept of the adaptability of the different kind of human, animal, and etc. plants and in tune with the requirement of the desertic condition. Climatic condition in the mountains certainly will vary from that of the Kerala and the coastal belt of the South India. So the thing is that our ecosystem diversity is enormous, and all those ecosystem diversity promote for the development of different biodiversity, starting from the microbes to the gigantic animals like blue whales and elephants, whatever it may be. The question is that why I'm telling all those things? Because these are the natural resources. And India is such a country which possesses what tremendous potential and diversity of natural resources in the form of the biological resources. India is such a country which possesses so many natural resources in the form of the mineral resources in different parts of the India. So our responsibility as a student, as a researcher, not only to understand that, please don't talk, please. Our intention is not to discuss all those things in the classroom on a hypothetical and theoretical manner, but to undertake something in the field in a practical manner so that we can learn from the very close vicinity of the natural resources. Do you know what does mean by the Arabari forest? It is a forest resource base. Okay, I understand, but it is a place which can be remembered because of its recognition of Paul Getty Award. That Paul Getty Award is equivalent to that of the Nobel Puruskar, Nobel Prize of other subjects like economics, health, or physics or chemistry, something like that. Do you know what does it mean by Paul Getty Awards? Because this Arabari model earned the status of the Paul Getty Award equivalent to the Nobel Prize in the field of the environment of its uniqueness, innovative idea of the management of the forest. So I think first thing is the natural resource, second thing is the categories and its distributional pattern, third thing is the management of the natural resource, fourth thing is that in a sustainable way, we should develop some strategy for harvesting, and fifth thing is that we should develop the strategy for harvesting for what? For the benefit of the human being. We can simultaneously develop something which will cater to the need of the society, not only for meeting up their food, fodder, shelter materials, aesthetic requirement, medicine, etc., etc. Because our entire survivability is dependent on all those natural resources, especially the biological resources. Third thing I just like to mention, okay, we know these things very well from our academic exercise in the classroom, I understand. But for what this seminar is meant for? The seminar is meant for to understand new and newer technology which have been emerged during the last couple of decades in the different parts of the world. One important statement in the field of the environmental science is that what? We should think globally. আমরা এখানে বসে থেকে শুধু থাকলে হবে না, we must be here to interact with our teachers and scientists, whatever it may be, but we must learn something from the global perspective. And that global perspective will not fulfill our aspiration with our purpose, with our objective. But this global knowledge ultimately will help us what? will help us to develop our innovative and indigenous technology by which we can harvest our own natural resources, like that of the Arabari model, like that of the Arabari forest, in such a way we can serve twofold purpose. One is the sustainability, another is to do something good for the human being in terms of his food, fodder, medicine, livelihood, etc., etc. So I am happy that this seminar has identified one important aspect. What is that? That is the geospatial science. Geospatial science is a recent development. When we were the student of the post-graduation around almost 4 decades back, we did not even hear about this subject. Okay, one of my fellow friend, Somnath Chaudhuri, from the geology department, because I had been to in an interdisciplinary field of research on the marine and oceanography. So Somnath was identified as a potential candidate. He joined there under the leadership of a civil engineer. Probably the name is Professor Chaudhuri. Then he started his journey with this geospatial technology, remote sensing, and etc., etc. After joining this university, around 3 decades back, I was happened to be a important person so far as my organizational position or administrative position is concerned. I remember that executive committee meeting when our then Vice Chancellor, Professor Anandadev Mukherjee, advocated strongly to start a specialization in the field of the remote sensing in the Department of the Geography. Okay, no one stood by the side of the sir, Professor Anandadev Mukherjee. I stood. Okay, sir, it is a good venture. I understand the need of this subject, because geography doesn't mean only to identify the resource base, but to do something for harvesting. In what way it is possible? So remote sensing is right now a emerging subject. I advocated along with the Professor Ananda Mukherjee, and our geography department started a journey with some specialization. And for your information, especially those who are the administrative setup in the college, Professor Deepal from the IIT Kharagpur was appointed. Although he did his BSc and MSc both in chemistry, but he joined in the Department of Geography as a reader. I utilized his expertise in an interdisciplinary national level project on the mangrove ecosystem of West Bengal. That is the NATP project, National Technology Development Project, along with the Keralan people, Andaman people, and other parts of the India, so that we can develop something. I understand this should be applied, because only surveying the ground truth will not serve the purpose. Because we were acquainted, we were very much competent in handling different biological resource, harvesting, sampling, processing, etc., etc. After visiting the different types of field, it is required. Not only sitting in a computerized room, only restricting ourselves on doing something about the geospatial and remote sensing satellite imaging laboratory, that will not serve the purpose. You will have to make a blend between the old and the new. Blend between the old traditional form with the emerging one. The old traditional form is to visit the field. You will to understand in what way Arabari forest is different from other part of the Kanha and Madhya Pradesh forest. In what way Sundarban has developed its uniqueness, which certainly differ from the forest region of the mountain and other thing. You shall have to develop this idea and feeling. After only possible by paying the visit to the field, you will have to understand the color of the soil so that you can have the idea what kind of organism may be present there. That is not possible from the geospatial remote sensing thing. You will have to, but simultaneously, that will not serve the purpose. The purpose will only be served if you can inculcate the knowledge base of the modern emerging subject, geospatial and remote sensing. Deepal was instrumental to contribute something about the geospatial and remote sensing, and afterwards, our university could develop a full-fledged department. I think Karthik is a product of that. I was just seeing Karthik, I was just, I was surprised, not only surprised, I was very delighted to see Karthik, because he was there with my project. I am a biologist, but Karthik along with his teacher were what? Remote sensing specialist. My friend Ashish Pal was the geography geomorphologist. Chemistry Phani Bhushan Ghosh, you might have heard the name of those person because he belonged to what? Marine science department, I understand. So those are the good time among all the persons who joined together in interdisciplinary form. So for what? for understanding not only nature, for do something in such a way, so we can explain the different ecological and environmental processes. Otherwise, it would not be possible. Botanists can identify the plants, zoologists can know about the chemistry, can do several things about the chemical analysis, but you will have to integrate all those things in a particular point in order to develop in an interdisciplinary, explain in a proper way. That is the demand of the time. So remote sensing and geospatial deployment in our zoology, Vidyasagar University was started, and he got the recognition of the Department of Science and Technology, DIST, FIST, etc. And I involved as a project coordinator in several of my projects to unravel the beauty, the mystery of the nature in such a way, involving Ashish Pal, Jyoti, Kartik, and so many of my friends, Dhoni, etc., to understand about the dynamics of the nature, dynamics of the environment in the form of a consultant in an environmental impact assessment. Engineers are okay, they know environment to some extent, but they do not know the ecology. So that is the problem. They know very well in what way a construction can be built up, but they do not know in what way that construction will impart something in the nature to cause the deterioration of the biological resources and other thing. And biological resources, starting from the microbes, can play a very pivotal role in sustaining the entire nature. So the thing is that it is the demand of the time to develop the interdisciplinary research. I am happy that this seminar, this organizer has taken up the responsibility. I have forgotten about the seminar. You know, yesterday my PA informed me, sir, you will have to go to the city college. I see. Oh, anyway, I will deliver a extempore talk based on my feeling, based on my emotion, based on my knowledge base, in order to what? In order to motivate our next generation. Okay, you know remote sensing well, but simultaneously you'll have to have very clear-cut, transparent idea about our natural-based resources surrounding you. You shall have to know about the Aravalli forest, what kind of composition of the plants in the forest system are there, which differ from the forest system of other places of India, this tropical deciduous forest. So, biological knowledge is also required, chemical knowledge is also required, but you will have to integrate all those things in such a way so you can actually do the proper justice of our research activity with the prime objective to do something good for the human being. That is the main motto, societal responsibility. Sangita is here, my student. When he approached me, sir, I do, after having molecular biology specialization, okay, you see that teeny, that is the Bellamia bengalensis, locally named as the googly, can do havoc in monitoring the global warming. So she did some good piece of work and published a good piece of research papers by which that Bellamia bengalensis can indicate the changes of our environmental system and in what way global warmings are going on and what impact it is going to impose on different biological creatures to the level of the biochemical and molecular entities. So the thing is that everything of our nature is interrelated, interlinked. We should not treat any resource base in an isolated manner. But whenever we are going to harvest anything, we must think twice about before harvesting all those things. Whenever we are going to impose or utilize any kind of technology, we must think twice about the sustainability of the entire processes. So many things are interrelated, interconnected. I do not like to prolong my lecture anymore, but one thing I must say to the students, you are the future generation, and I am happy that organizer has identified Kakuli Madam, Jadov sir, and Pavitra Babu from the Indian Statistical Institute, and many other persons from other parts of the Midnapore and West Bengal too, and Nirmalda is there. Nirmalda is the repository of so many knowledge base. I am enjoying that Nirmalda is listening my lecture. I am very happy. He is a very knowledgeable person. You are very fortunate to get a person like Nirmalda, and so many persons are there also who used to visit this college. I understand, I know. So try to extract as maximum as possible from all those things. I am just recollecting my memories of the Vidyasagar University around 3 decades back when we started our journey, but without having anything. But the thing is that we were able to involve so many leading personalities of the India, especially Bengal and Calcutta, in the campus of the Vidyasagar University. They used to visit and they enjoyed very much. Their company, our company, they stay in the Vidyasagar University. And they spend a lot of times with the students of us, and they shared their knowledge with the students. Debojyoti Das, you know, a renowned scientist, a renowned teacher in the Presidency College on the biochemistry and statistics. Recently he's expired, just a few days back. He told me once, Sushanto, I happen to be a successful teacher or influential teacher of the Presidency College, but I have got a new life in your campus. So I am teaching by microbiology, thereafter zoology, then botany, then and all the students rush to me. They try to extract as maximum as possible knowledge in terms of the biochemical world, in terms of the statistical analysis, etc., from me. I'm overwhelmed. This is the main feeling of a teacher. So I'm not elaborating all of those things in detail, but it is the strength of our mind that has that imparted a lot of confidence in our mind also. So that's why in the year 2009, where I went with the Dean Faculty of Science along with Sankodda, just a couple of days back in the Sunday, a reunion was there about the English students, and all the students are very well placed in and around India. I am happy as a Vice Chancellor. Sankodda and other faculties who retired came to that occasion, was telling that I, along with Sushanto as the Dean, could do havoc by impressing the NAC, so that we stood third position after the Calcutta and Jadavpur on that day, on that year, 2009, in the ranking, keeping behind that Bardhaman, Kollani, North Bengal and other universities because of our concerted effort, because of our committed effort, because of the heartfelt involvement as a teacher, not only by imparting our own activities on things, but also by involving so many personalities. Whenever Pradeep Babu ranked me, sir, I immediately narrated the name of around 10 and 8 experts member. If they can be involved, I am sure they can challenge any university of the world, because they are the actually knowledgeable persons who can tackle in any subject. So the thing is that I am happy. Only 3 or 4 months, or not, before my assuming I came to this college. I was impressed. I expressed my happiness to Kuntal at that time. Okay, you are going in a right direction, go ahead. So I think your performance is only reflected with the satisfaction of our students, that the way we are receiving right now, most of the students are well placed in different parts of India, not only India, in Cambridge, Oxford, Stanford, and etc. So in what way? The rural-based students, after having their degree from a rural-based university, getting the support from a person like us, are right now placed in the different parts of the world. That is the main satisfaction. And that satisfaction can be earned by organizing this kind of seminar and enabling such person like me to share my feeling with the students especially, so that they can get some more confidence, so they get some more direction for their future mode of life. Thank you very much.
Please give a huge round of applause for our Honorable Vice Chancellor, Professor Sushant Kumar Chakraborty, sir. So now we would now proceed further. Sir has, within a very short span of time, beautifully explained the importance of interdisciplinary research and also how we can sustainably manage our resources. So again, it was a privilege for us to have with us today our Honorable Vice Chancellor. Now I would like to invite our Vice Principal, Dr. Kuntal Ghosh sir, for setting a welcoming atmosphere for this event.
Honorable Director Sir, eminent scientists across the India, Professor Nirmal Kumar Sarkar, my colleagues and dear students and delegates. A very good morning to all of you. I think we had a very impressive talk from our Honorable Vice Chancellor of the Vidyasagar University. So on behalf of the Midnapore City College, I would like to cordially welcome you all to this 2 days National Symposium on the application of the geospatial science for the national resource management, sponsored by the SERB government of India. We are very much fortunate to have Professor Sushant Kumar Chakraborty, Honorable Vice Chancellor of the Vidyasagar University, in this inauguration program as an inaugurator. We are very much fortunate to have the eminent speakers from different research and the educational institutes working in the geospatial science. I especially welcome Professor Pavitra Bonik from the Indian Statistical Institute, Kolkata, Dr. Kakuli Banerjee from the Central University of the Orissa, and Professor Dr. Kiran Jalem from the Central University of the Jharkhand. So I welcome all of the participants to this symposium. Now I am going to give you a brief introduction about our college, Midnapore City College is specifically a self-financing general degree college in the West Bengal, which is recognized by the UGC, DSR, Government of India, Higher Education Department, Director of the Medical Education, Government of the West Bengal, and affiliated to Vidyasagar University and the West Bengal University of the Health Sciences. Currently, 19 UG courses and 22 PG courses are being taught in this college. A biodiversity and the environmental studies research center is also running in this college under the Vidyasagar University. The college received 10 extramural research grants from different funding agencies like ICMR and the SERB Government of the India. The faculty members and the research scholars publish around 120 research articles and the book chapters in different national and the international journals or the publishers. The college also signed the MOU with the Rush University of the Medical Center, Chicago, USA, and the Jeonbuk National University, South Korea, for promoting the research activities. So basically the aim of this symposium is to bring together the brilliant minds involved in the past discoveries, ongoing researches, and with the upcoming discoveries which may be helpful for the researchers, scientists, students, and anyone related to the growth of the informatics in terms of the geospatial science and the allied fields. So we are very much thankful to the SERB Government of India for sponsoring this symposium. Without their generous financial support, it would not have been possible to organize. And also I am very much thankful to Dr. Pradeep Ghosh, founder director of this Midnapore City College, for continuous support and advices which have greatly helped towards the successful organization of this symposium. And my thanks to Dr. Sudipta Chakraborty, Principal, Midnapore City College, for his cooperation. I thank all of the invited speakers and delegates for their enthusiastic participation in this conference, and also a special thanks to Dr. Kartik Bera, convener of this symposium, and Dr. Shravani Pradhan for guiding the team to achieve the funding from the SERB Government of India. And I must acknowledge the unwavering support received from all faculty and the staff members of Midnapore City College. Hope you enjoy the scientific session. Thank you.
Thank you, sir, for delivering the keynote welcome address. Now, it is time for our keynote speech. The keynote speaker is a man of great caliber and influence. Professor Pavitra Bonik is a distinguished researcher at the Indian Statistical Institute. I will give a very brief introduction about him. He specializes in rice-based cropping system and utilizes GIS tools for natural resource management. His research focuses on farmers' technology adoption, and he actively contributes as a council member of the Indian Society of Agriculture. Serving as an associate editor for scientific journals, Professor Bonik supervises PhD candidates and leads projects in sustainable agriculture and rural development, reflecting his dedicated efforts to advance agricultural sciences and technology adoption in the Eastern Plateau region. It's a great honor for us, sir, to have you with us today as our keynote speaker. So please welcome on stage Professor Pavitra Bonik from Indian Statistical Institute, Kolkata, West Bengal, as a keynote speaker for this symposium.
Thank you, ma'am, for your generous introduction and few generous words regarding me. I would like to thank the Midnapore principal of the director, Midnapore City College, principal, vice principal of the Midnapore City College, and my special thanks go to Kartik Bera, who has happened to my student, my postdoc students at ISI. Okay, so as he requested me to come, so I could not avoid this. That's why I am here. And I'm very glad to see the audience. Even in Kolkata, it is very rare, even in ISI also, to have such a gathering in any, meeting or any symposium. So I'm very glad to see this interest of the students and the teachers also. So now I would like to give very brief introduction about my talk, and I don't think it will take more than 40 minutes or 30 to 35 minutes. I'll try to finish my talk. Okay, initially I will say about what is AI and artificial intelligence and machine learning. Then I will give some idea about natural resource management. Okay. And finally, as you know, that the natural resource management are essentially related to agriculture. So I will give some idea about agriculture also as well. So let me say that this is the topic of my today's talk, the application of artificial intelligence and machine learning in natural resource management with reference to agriculture. And as you see that I am also attached with Center for Artificial Intelligence and Machine Learning, which is a center founded by ISI, founded by our director in the ISI, and also Ideas Technology Innovation Hub. That's a very new, innovative, launched by the central government. And anybody, Ideas is a private organization, and under Section 8, okay. So TIH is Technology Innovation Hub. I would like to give in details about this, as because anybody can submit proposal. And I am an active or associate member of this hub. So if you submit any proposal which has some, what do you say, that which should have some marketable value. We are very much interested about to market whatever you are doing the research, so there will be an end product, and you can market it. So startup is also one of their parts. So anybody from your part, if you are interested, you can submit the project. It is, if you go through this website, you can find it. Okay, the TIH website, Ideas TIH website, and it is very easy to get the fund if you have a very potential project. There will be no, red ribbon, all those things, as it's a private company. Funded by the government, 100 crores, more than 100 crores government has given, and there are only 25 that type of TIH all over India. So ISI one of them. Okay, so let me start my, now let me start with what is AI, artificial intelligence. As you know that artificial intelligence, it's a very common, very hot topic nowadays. Artificial intelligence, deep learning, machine learning, these are all very hot. বাংলা যাকে বলে খুব খাচ্ছে আজকাল scientific community. আগে ছিল, earlier it was the spatial analysis or the GIS and remote sensing. Now this is AI and ML. Although this GIS and remote sensing comes under this ML, machine learning. Okay, so what is AI? Artificial intelligence means if we simulate the intelligence, human-like intelligence in the machine, particularly in computer, that is called the artificial intelligence. Before that, there was a fuzzy logic. What is fuzzy logic? Means, although that is not totally logical, but if you like to do some work through your computer, earlier we told that it's a foolish box. One computer, one TV is a foolish box, boka baksho. Nowadays it is not a foolish box. It can. I have seen one robot which can do everything. Okay, if you ask any question, that robot is capable to reply. So now our intention is that to produce such a machine, such a computer which can interact, which can incorporating the intelligence of the human, that so machine will be intelligent so that it can perform like human being. So there are different type of artificial intelligences. As you know that Alexa, all of you might be aware about the Alexa. If you say, Alexa, please do this, Alexa will do that. Alexa, please switch on the your fan or TV. If those are interrelated, Alexa can do that. So this is called the narrow AI. This is very weak AI. So it can do only single function. And there is another AI that is called the general AI, which can do multiple function. Then comes the machine learning. So in machine learning, actually basically it is machine learning means where the geospatial analysis or GIS, remote sensing, everything, big data analysis, everything comes under this machine learning. Deep learning is also neural networking system that comes under the deep learning. Okay, and most importantly, that is the robotics, and all of you might be aware the function or the importance of robotics. Even any critical operation can be done through robotics. Okay, not only the operation, the main work of the robot or robotics, you can use this robotics in agriculture or any source of work. Nowadays, without driver, okay, running a vehicle is very common in, and that is a function of this AI. So now AI, and as I mentioned in my lecture title, that the agriculture, so AI and ML in agriculture sector, scenario in India. The scenario, that means the involvement of AI and ML in agriculture is very, very scanty or very scarce, very limited. Only Microsoft and ICRISAT, they are doing some work as requested by the Niti Aayog. Niti Aayog is, as you know, that this is the think tank of India. So whatever the Niti Aayog decides, that will be, applicable for all, particularly policy-related matters. So now Microsoft and ICRISAT, they have done particularly to identify the sowing portion, the sowing windows of any crop in Andhra Pradesh and Karnataka only. So this is the part of this AI and ML in agriculture. Although I will give details about the ML in agriculture also. So application of AI and ML in agricultural management. So I would like to highlight only this: precision farming and site-specific management, water management, irrigation, soil management, weed management. These three things where we can use these AI very efficiently, very appropriately. As because this water management, water is a natural resources. I will come later. So particularly these three: precision farming and site-specific management, water management and irrigation, soil management and weed management. I will cover these four things under my lecture. Okay. Now, AI and ML, an initiative towards national resource management. If we say what is national resources, whatever the my earlier speaker, Honorable Vice Chancellor, told you that whatever is available in nature, that is, and if that thing is useful for human being or for the society, can be considered as a resource, natural resource. So even the crop, now we are doing any cropping system, any agriculture system, suppose rice. Basically rice is a natural resource. As because we domesticated the wild rice variety into a crop. That's why it's a natural resource. So without nature you can't think anything. Okay. So now if we, but in general, we consider the natural resources, mainly three things. One is the land resources, another in land including the forest resources, second is water resources, third one is human labor resources or human resources. These are the main three components of the natural resources. Okay. But apart from that, there are a lot, huge, everything comes under the natural resources, which is available in nature. So if you consider this land use pattern, this is very important. Suppose it is not possible to you to go to each corner, each site of your state or of the country to identify what is going on or what is there. So this ML, machine learning or remote sensing, gives you the opportunity to identify. So this is the map. This is the map of Purulia district. You see, this is big, water bodies, and these green areas means. So at first, we have one image. Then I will come later how to do this type of output. Okay, and I would like to show here only thing from district to, these are the blocks of Purulia, Arsa, Bandwan, and this is one very village in Jharkhand that is called the Lukpi village in Bengabad block. Okay, so even if we have these resources, these GIS technologies with us, if we have this remote sensing technology with us, we can go to the even village level. Earlier, it was impossible to think about it to go to the village level. So at micro level, planning, this village level, mapping is very much important to identify the natural resources, the land use pattern of a village. To identify that, it is very important. Now, I would like to show you these three, as you know that this is the picture of South Chobis Pargana and some parts of the North Chobis Pargana. So this is Sundarban areas, Indian Sundarban. Okay, so you see this is the picture of 2018, 1985 and 1972. I would like to concentrate on particularly this, island. You see this island, and now this is becoming although the scale are the same. So from this picture, it is clear that these islands, there is some waters are dipping down in the sea. So as all the scientists globally, they are saying that prediction is that within few days, few years, all the coastal areas will be underwater. So my study also proved, my study also proves these islands, okay. And the coloration, that does not mean, just due to this is the Landsat 8, this is Landsat 5, so Landsat is the satellite name, and due to this satellite difference, this coloration is differs. But there is a degradation of, as you know, that the entire area in 1972 was green, so the forest was dense. Now these areas become degraded. So these are considered as a degraded forest. So again, if you think about the entire area, big area, so you see this is Bihar, Jharkhand and West Bengal. This is the soil map, topography map. Topography means the elevation. So if you know the elevation, you can plan the water resources, everything, how to do the irrigation, everything. And this is the picture, the satellite image, okay, and from where we have cutted these different, Purulia and different areas. This is the Purulia district and some blocks with some villages. I will give you later about the villages. So these are the blocks of Purulia district. So we can scale down. I would like to emphasize on it that we can, through this GIS and remote sensing, we can identify the water resources or the land resources. And particularly, if you have a medium land, if that land can hold moisture, then you can think about double cropping. You can think about intercropping or something like that. But if it is a upland and there is no water resources, you cannot think about more than one crop. Only you can grow the monsoon crop. Okay. So land use pattern is very important, and the scaling down of this land use pattern will help the policy makers to make the policy at micro level, which is now lacking. You know, these Niti Aayog people, they are sitting in Delhi under aircon room, and they are making some policies without visiting any areas. So this is the main problem of India. So I don't like to elaborate all those things. This is land use pattern of Purulia 2, that is called Purulia 2 block. There are 2 blocks, Purulia 1 and Purulia 2, and these are forest area and everything is there. So if you have the temporal data of this image, then you can identify what type of changes is going on there. So not only the land use pattern, you can also have the changes. You can identify the changes. So it plays a very vital role. Manbazar block, Manbazar 2. This is very interesting one. This is the village level data, not the block level. And this pie chart indicates the land use pattern, forest areas, other areas, etc., etc. Okay. So, and these are the these are the some villages of Purulia district and of different blocks. Now, Purulia district area statistics in hectare. Above these areas, these forest areas and everything we have calculated from our remote sense data. And this is the Simulia, Baligara, and this is Baligara, Simulia. These are the census data. And the differences are 0.12, 0.08%, 0.01%, 0.05%. You see the differences? So, if you use wisely the natural resources, the remote sensing and GIS, you can identify, so you can minimize the work of the census. Census is a huge work done by the government of India. So GIS and remote sensing can also do the same type of work without employing huge number of people, and there will be an enormous human error. Chances of human error, at least 12% human error. We generally, discounted 12% general. So this is the village which I have shown you earlier, Lupi village. And this map was done by the PRA, Participatory Resource Appraisal. And I will show you later the same image. So you see these are the different, these are the different, mohalla or tola. They call the tola. Okay. So these are the different where the settlements were there. Now this is the ethnic group composition. We have done the entire thing using GIS and remote sensing. So this remote sensing has a tremendous power to give you a big knowledge base, information base of even a village level, not a border level. In broad level it can do, everybody knows, but even in the village level it can do this. Okay, and this is the map what I showed you earlier. So through this map, doing the hybrid method of classification, that is non-supervised classification first, then trailing some areas and then do the supervised classification, you can identify some of the areas. You saw upper terrace means upland, medium land, lowland. If there is a more medium land, so you can advocate or you can recommend that people can do, the farmers can do the second crop, third crop, etc., etc. So this is all about the land resources. Okay, using GIS and remote sensing. Now if we come to the water resources, so the main water resources, natural water resources is the rainfall only. As you know, we have some underground water or groundwater, and the main source of the groundwater is the rainfall. If there is a scarcity of rainfall for a longer period, the groundwater level will decrease, and it will not be possible to extract the water to do the agriculture. So main resource of water is rainfall. Now, these are the rainfall stations, different rainfall stations of West Bengal. So, this is very unique, and the problem is also unique. Suppose the rainfall station means the station data, and this station data is designated as, or is known as, or is bounded by the administrative boundary. Okay. Suppose Alipur, there is a rainfall station or meteorological station. In Damdam, there is another meteorological station. As soon as you cross the Alipur administrative boundary, the rainfall data will be changed. Okay, suppose in a particular, suppose in 22nd March or June, the rainfall of Alipur is 20 millimeter, and in Damdam it is 5 millimeter. So that means as soon as cross the political boundary, the rainfall become 5 millimeter. So this is called the discrete, from natural to discrete, but rainfall is a natural phenomena. It cannot be a discrete values. So this is the main problem. And as per government rule, every block should have a rainfall station or weather station, primary weather station. Every block should have. This is the policy of the government. But unfortunately, we do not have. The India government does not have this rainfall station for each. Even we, the meteorologists, we know that it is very common for us. If you have two rain gauge through which you can measure the rainfall in your two hands, there will be a differences in reading. As that means the rainfall is so dynamic, so variable. So it is not possible to identify from a station a big area or a boundary. So what to do? In that case, what to do? So in that case, we can do the spatial interpolation. Till date, before doing our work, till date. So this is whatever we can do. I have given the gist in this slide. Now meteorology data, what type of data we have used? Base map. Just go through it. I don't like to repeat all those things. Spatial interpolation, that is the only way to smoothing the rainfall data from discrete to normal. Okay, that is called the spatial interpolation. And there are several spatial interpolation methods. Before that, globally, it was used, kriging was used for spatial interpolation, which is a stochastic method. Dynamic method and dynamic modeling and stochastic modeling. There is a hell and heaven difference on the dynamic and stochastic modeling. Stochastic modeling, we have assumed so many things. In case of dynamic modeling, we assume very minimum. We also assume something, but that will be very minimum. So through our work, we have used three methods. Inverse distance weighting method, IDW, spline method, and kriging method for doing the spatial interpolation of rainfall, which is very important. Okay, so and we have verify which method is the best using these two very simple statistical tools, MAD and MSD, mean absolute deviation. That means within mode, if you identify the deviation from the mean, and mean squared deviation. Okay, through this we have identified that IDW is the best, and my data. If you have the reality, if you go to the areas, you see 22nd SMW standard meteorological week. Standard meteorological week starts from 1 to 7. January 1 to 7 is the standard meteorological week 1. And this way, 52 standard meteorological week, but there will be 1 or 2 days, depending on the leap year extra. So we add this 1 to 2 days on the last 52nd standard meteorological week. So this way, we generally do the rainfalls. We generally study the rainfall on the weekly basis, standard meteorological week. At least I prefer. There are several ways to do this meteorological rainfall study. Pentad rainfall study, decade rainfall study, pentad 5 days rainfall study, 10 days rainfall study, and weekly rainfall study. But I prefer to do this weekly rainfall study, as our interest, being an agronomist, being an agriculturist, our interest is to correlate this rainfall with the crop. As the moderator told that I am basically the rice scientist, so my interest is rice, and rice growth stages you can classify depending on the week. 22nd week, 23rd standard meteorological week, 24th this way. So if you have this weekly data, that will be easier to you to identify that which week is more, vulnerable, or more, vulnerable to stress, to water stress, to fertilizer stress, or any other stresses. Okay. So as you know that the maximum tillering stage, tiller paskati berono, tiller maximum tillering stage, and the flowering stage. These two stages are the most vulnerable for any trace. So we have identified this, and if you do the spatial interpolation by kriging, by IDW, and by spline, you see these IDW, these Kuch Bihar areas, this is Kuch Bihar and some parts of Jalpaiguri, and these areas is the heavy rainfall areas of West Bengal. Okay. And 22nd week, as we know that 22nd week there is a very small chances of rainfall all over the West Bengal. But spline is showing that on 22nd standard meteorological week there is a huge rainfall, and this kriging is also giving us misleading. This data is also misleading. So I think up to some extent this data is more accurate. So we have identified that IDW is the best method, and we have published this article in MOSOM journal. They have, MOSOM is the, IMD, India Meteorological Department's journal. So they have recognized our work. So at 31st meteorological week and 40th meteorological week. 40th meteorological week is very important, as because that is the end of October, near about. So that time the rice is at harvesting stage. So if there is, or before harvesting stage, maturity stage, if there is no rainfall, I think there will be no effect on the crop. When it becomes matured, there will be no effect. But this 31st meteorological week very important. And if you do this using spline, the spatial interpolation, then you will mislead. It will mislead you, and I will mislead the farmers. I will recommend wrong recommendation. I will give the wrong recommendation to the farmers. If you use this, if you use IDW, then up to some extent, not exactly so, but up to some, as rainfall is a very dynamic one. So up to some extent, I will give a proper, information to the farmers. So this is the, again, if we change the scale, earlier it was only West Bengal. Now if you consider West Bengal, Jharkhand and Bihar, then the scenario is this. Now start of transplanting, that is very important, as because there is a fixed window for transplanting. Okay, if you cross that window, and after crossing that window, if you transplant the rice crop, then you cannot expect a good harvest of crop. Okay, so our data, and which can govern your transplanting, only the rainfall, as because transplanting means the you have to have, or your soil have to have some standing water, so that you can transplant. Without standing water, it is not possible to transplant. So this work in broader sense, that means the West Bengal, Jharkhand and Bihar give you some idea about the transplanting. Greener parts are showing you, that is the alluvial part, Gangetic alluvial areas, that will give you more chances to transplant so many times. Start weeks. Which one? 2017, 27, this. Water storage at the week of 23rd. Okay. If there is no water storage in the 23rd week, you cannot transplant. Again. So this way, using these are some of the examples. Using these tools, GIS and remote sensing, you can do a lot. you can do the rice cropping system, the rice, even transplanting window in a particular area. Water storage at 44 standard meteorological week. Number of weeks without standing water. If the number of weeks is more without standing water, that means your sowing of your rice crop is at risk. Okay. So I would like to here mention that I have also developed one very small model that is called the MAI, moisture availability model, MAI index. That is simply the water coming and water going. PET, potential evapotranspiration, is water expend or water going out, and water coming is rainfall. If PET divided by water rainfall, if rainfall divided by PET, then if it is more than 1, that means you are in positive side. Your rainfall is more than your loss. So through this you can identify a particular area, only through this very simple model. You can identify a particular area, that which crop is possible, and you can advocate which crop, rice or some other crops, etc. Now I would like to give you, so I have already mentioned these two things, land and water. Now come to waste management. Waste is another resources. Whether you understand or whether you believe or not, but it is fact that these wastes are all natural wastes. As because these are either the crop waste or the farmyard waste or the municipality solid waste, whatever it may be. Those are all natural. So how to manage this waste? You can do vermicomposting through that waste to manage those waste. What is vermicomposting? The earthworm. Earthworm is the key, component or key point parameters for vermicomposting. Particularly this earthworm, we generally use the Echinacea fetida, which is an Australian breed and which is very much suitable for Indian climate. Okay, so if you have some waste, biodegradable waste, and you just semi-decompose biodegradable waste and allow this earthworm to eat that biodegradable waste, and the excreta, which is passes through its alimentary canal, through its girth, and whatever the excreta comes out, that is called the vermicompost. That is rich in nitrogen, phosphorus, potash. Not only that, it can have the hormones as well as auxin, and some pesticidal properties will be there. 3 of my students did their PhD on vermicomposting. So I have done up to some extent some of the aspect of vermicompost. How to increase the efficiency, as Vice Chancellor, Honorable Vice Chancellor, he told that the development should be sustainable. So it cannot be sustainable if you increase your production by using the chemical fertilizer. As because suppose urea or ammonium sulfate, you are giving the ammonium sulfate. Ammonia can be utilized by the bacteria and can be utilized by the crop. Okay, by a different way. But the sulfate part will remain in the soil. And this sulfate, when come in touch with water, it will become the sulfuric acid, which will increase the acidity of the soil. Okay, that's why, and if you use the pesticide, more fungicides, that will kill, not only kill the pest, kill the weeds, that will also kill the most important thing is the microorganisms, which is the cook of plant. As because without microorganism, you cannot, whatever the elements is there, suppose if your soil having more nitrogen, phosphorus, potash, but there is no microorganism, plant cannot uptake anything. As because those microorganisms make it available to the plant, bacteria, particularly bacteria. So these agrochemicals also kill those useful bacteria. So my intention is to, and we are saying that either use the integrated nutrient management or the organic farming, whatever it may be. If you go for organic farming, it is not possible to get compost, cow dung, or for the entire whole of India. But if you increase the nutrient percentage, the concentration of elements, concentration of NPK and some other useful elements. And if you advocate that to the farmers, then, and this vermicompost can be produced by the farmers itself. No need to buy those fertilizers. Nowadays, there is a big, chaos in capturing those fertilizers. There are RMP, MRP, minimum retail price. But those fertilizer dealers, they are extracting money from the farmers, more money from the farmers. So these earthworms, and these are the different works which can do by the earthworm. Now I would like to show you that the differences of cow dung, and if you make those vermicompost from the cow dung, then what will be the percentage of different useful nutrients in vermicompost and in cow dung. Organic carbon is almost the same, or it is less, as because we need a particular CN ratio for harvesting a good yield from any crop. So nitrogen percentage, you see, that is almost 3 times more in vermicompost. Total nitrogen, total P is double, total K is almost 3 times more. And most important thing is, you see, total copper in cow dung, it is 249.2 milligram per kg. Zinc 238.4 milligram per kg, but when it becomes vermicompost, it is 164. That it not only increases the useful elements, but also the earthworm can act as a bioabsorber. It can absorb the harmful elements, harmful nutrients, that is heavy metals in its body. So this both way, this is very useful. So I told you that the resources, what are those resources? That crop residues, weed biomass, aquatic weeds, vegetative waste, leaf litter, hotel refuses, waste from agro industries, biodegradable portion of urban and rural waste. So these waste are all natural. Okay. So, and that can be converted into the vermicompost using earthworms, and the methodology is very easy. So I think I can skip. This is very important thing. That if we add some cellulitic and lignocellulitic decomposer, that means the bacteria, to the bedding materials, to the biodegradable organic. As I told you, the vermicomposting, there is 2 parts. One is decomposition part, another one is vermicomposting part, passing through the girth of the earthworm. So semi-decomposition part, and our intention, if we being a businessman or being a entrepreneur, our intention is to produce the vermicompost with more nutrient concentration, number 1, number 2, to make it as early as possible, so that we can produce huge amount of vermicompost. So these cellulitic and lignocellulitic bacteria will help to decompose the biodegradable substances faster. Now vermicompost, this is an age-old practice to make the vermicompost. Earlier, when 10,000 years ago, whatever we produce are naturally produced. We do not have any fertilizer, we do not have any machineries. Then where from these crops got those fertility? From this earthworm. The soil is full of earthworms that time. So, but it is not possible, and it is very easy. If you have one small, even what do you call that, saucepan or sometime that is container, and if you have some semi-decomposed materials and add some bacteria, and the ratio is 12 to 15 earthworms, matured earthworm per kilo of biodegradable substances, and then you can produce the vermicompost. This is very easy and common method. But if you think as an entrepreneurship of vermicomposting, nowadays the tea gardens, they are very much owners of the tea garden, they are very much interested to use vermicompost. As you know, I think you might be aware that most of the teas are losing their import values. They are refunding due to the fertilizer residues, due to the pesticide residues, due to the insecticide residues. So if you use this vermicompost, then there is no need to, red mites is very common in tea. So no need to apply those pesticide and all those things. Your vermicompost can act as a pesticide also. So this is the automated system to produce the vermicompost. This is developed by, in collaboration with IIT Kharagpur, Professor B.C. Ghosh. I worked with Professor B.C. Ghosh and we have developed this. Mixing, you have to mix first those cow dung and biodegradable substances, and there is a, you can see there is a motor at the top, and you can rotate this, so there will be a mixing. And then through this pulley, belt and pulley, you can transfer those mixing materials from the from this area to your tank where you can make the vermicompost. And this is the different types of tank. Make bed, or more appropriately you can say these are the different types of bed. And if you see minutely, there is some slanting. So if there is a excess of moisture, that will come down, that will be drained out. And don't waste that drain out part. That can be considered as a vermi wash. And there is a huge possibility. If you condense those vermi wash, what is the main problem of using organic substances in agriculture? As because it's a bulk in amount, 10 tons, 15 tons. Okay, so it is very tough to handle 10 tons, 15 tons amount of thing for single hectare or 10,000 meter square of area. So even in vermicompost also, you need at least 5 ton to 8 ton you have to apply to fertilize your crop. Now if you make those vermi wash and condense it, so you can get a concentrated form of vermi wash, and if you mix it with the water, that will be easy to handle. That can attract those businessmen as well as entrepreneurs as well as the farmers. Okay, no work has been done yet on particularly this part. And this is the mixing, how to separate those vermicompost this way. If you put those vermicompost from the bed on the from the top of the ear, and then you will get, there is a mess, and you will get the fresh vermi, and there is a hot water blow. Due to this hot water blow, it will dry up, and you can harvest those vermicompost readily. And you can, we have done another work, research work on vermicomposting. As you know that this is a biological product, so there will be a shelf life. And we have seen that if you keep those vermicompost up to 45 days, the nitrogen percentage will increase, but at the same time the phosphate and potash percentage will decrease. So as you know that nitrogen is the most important, so you can recycle, you can, I mean to say marketable. So you have 45 days with you to market this vermicompost. So each farmer can do this type of thing, not in a big, form, but in a small form, can easily do this. That is also another way of natural resource management. And this is very primitive type of thing. I would like to compare this to another one is highly mechanized. This is very primitive type of thing. You see, and you have to water. So if you use the sprinkler water, micro sprinkler, alternate day, that will sufficient for to irrigate, to make your vermicompost moisten. And you can harvest this way. So this is another way of vermicomposting. Now if I consider this human resource, how to manage these human resources, and that will the end of my lecture. I think you some of you are feeling bored, but as this is my responsibility to give the keynote address, so I have to cover the entire area. That's why I'm. So the manpower. So maximum manpower is utilized, is required in agriculture. Earlier it was 70%. 70% worker need to feed 100 people. That means 70% of our population were engaged in agriculture. Now it is 37%, 47%. So we have already minimized it. But again, in European country, they need only 6% to feed 100 people. We need 47 people. So that means there is a possibility to minimize the human resources. Okay. So if you minimize the human resources, we can utilize those human resources to other works. Is not it? So one of the most human required, activities in agriculture is weeding. To identify the weed, to eradicate the weed, either to manually or using some spade or chemically. If you use the chemical, then again it will not be a sustainable way. Clear? So we have identified one of my PhD students, he is doing the work. So these are all the very common thing. I think all of you might be aware of this, how to use this weedicide, very judiciously use. If you use the blanket amount of weedicide, then there will be some bad effect. So our intention is to use very minimum which is required for weeding. Weedicide, if it is not possible to avoid it. So the new approach for weed management, what are the new approaches? No till. If you do not till your soil, if you do not plow your soil, there will be a possibility of less weeding, weed growth. Okay. And non-chemical methods, there are non-chemical methods, flaming. Again, if you burn these stubbles or weeds, then like Delhi, there will be a huge chaos. So new generation chemicals. New generation chemicals mean synthetic pyrethroids. If you use synthetic pyrethroids and if your weed become resistant to those pyrethroids, synthetic pyrethroids, then it will be very tough to kill those weeds later on. Biotechnology, bioengineering you can do. Again, in bioengineering, the naturalists or ecologists, they have some reservation, as because bioengineering maximum cases we generally incorporate the animal gene into the plant gene. This is not favorable, or acceptable thing, as because in this plant gene system, if you incorporate one animal gene, you don't know what will happen. So use of artificial intelligence is the only way to minimize the use of weedicide. How it can be done, I will show you. Mapping of weed population through remote sensing tools. You can map the weed population using remote sensing data, weed seeker, unmanned aircraft or drone, mechanical weeding through robotics, and precision herbicide application. So this is the main work which is done by my students now, and he is doing PhD in computer science in ISI. So you see, through his this modeling, he can identify that these red coloration, these are the weeds, and green colorations are the crop. These are the crops and these are the weeds. So if you identify that these are the only weeds and these are the crops, then you can apply those weedicides specifically as those areas. So this is the application areas, only these areas. So most judiciously you can use the weedicide through this AI, artificial intelligence. So through these you can minimize the human laborer in agriculture, and this way AI or ML can help you to minimize the human resources. Current status, What is the current status? You see, we have a doubt that in 2050 India will be sufficient for, will be or capable to do that type of thing. Although research is going on, but whatever the research is mainly going on in South Korea, Australia, USA, Belgium, Germany, China, not in India. Now in IIT also, and we are also trying in a very small scale to develop that type of algorithm so that we can identify using AI. And next I will show you, I would like to skip this. This one, this is a very new concept. I would like to show you. You know this acoustic emission. What is acoustic emission? Although there is a very little work, I think nil have been done on acoustic emission. Acoustics means a sound which is above our audible range, more than 20 kilohertz. If the sound is more than 20 kilohertz, then we cannot hear it. Our ear cannot hear those. So plant, this aquatic emission, plant produces these sounds. It has been seen that plant, a normal plant can produce one beep sound once in an hour. Okay, beep sound, but we cannot hear it as because its frequency is more than 20 kilohertz. If you have an aquatic box and if you have this type of microphones, then you can only capture those. Suppose. Okay. So, these experiment, at present, we are doing this experiment in our greenhouse. Okay. We are growing rice with elevated arsenic. So, the plant is in a trace. Oh, I have finished. I did not finish the earlier one. One beep, normal condition. If there is a trace, either water trace or any trace, it can produce 5 to 6 beeps in an hour. If the traces are more, that means plant is going to die, then it produces 200, 300 beeps in an hour. So if you can capture those beeps, and if you can capture, if you can convert those beeps, the frequency of those beeps, and it is not possible by any other means except AI, artificial intelligence, then you can say there is a possibility that due to water trace it can produce a particular type of frequencies, beep frequency. This is a possibility. That's why it is under research. We don't know what happened. If there is a arsenic or water salt trace, then there is a possibility the frequency will be something else. If you identify those frequencies, those sound frequencies, ultrasonic sound frequencies for different traces, then can you imagine what happened? Without doing any research, anything, just capturing those beep sound, acoustic emission, you can say your plant is facing this problem, either water problem or trace problem or nitrogen problem or sulfur problem. So this is the, what I say, not only the latest, very latest research which is going on globally. If you go through this, internet, you can find hardly one or two article on acoustic emission. So this is very challenging as well as very interesting one. So if we can do, that will also minimize the human resources in agriculture in huge amount. And that's all. Is there any question? Yes, sure.
In Sundarbans, there is another concept of cultivation of rice cum fish culture or rice cum duck culture like that. So in that case, wouldn't it affect your acoustic sound? Will it give us a similar type of a signature? I don't think so.
No,
because if the plant
actually,
is
let me say you, in field condition, you need one acoustic box. You have to put the crop within the aquatic box, okay, and within that box there will be that type of microphone.
Yeah.
And this microphone will capture those sounds. And you should have one software. That software, nowadays software is available that can convert those sounds into the, frequencies.
Different frequencies.
Frequencies. But it is not possible to identify each and every frequencies. That's why we need to develop the AI frequencies. And as you place your crop within the aquatic box, so there will be no disturbance from others.
Even the stress, the different type of stress can be identified with this AI?
That's
No, that has not yet been come up.
that's not yet come up. That's why it is
Yes,
under research.
yes. Thank you, sir. Thank you.
May I remove this? Any? Is there any question?
So any students, if you have any questions, then you can raise your hand. কেউ কিছু প্রশ্ন করবে?
ভার্মি কম্পোস্টিং নিয়ে প্রশ্ন হওয়া উচিত, কেননা ওটা তোমাদের ডে টু ডে লাইফের সঙ্গে যুক্ত। তোমরা যদি চাও বাড়িতে করতে পারো।
স্যার বাংলাতেই উত্তর দেবেন, তো তোমরা
ইউ
যদি
ক্যান
চাও
আস্ক ইন বেঙ্গলি, বাংলাতে প্রশ্ন করতে পারো, নো প্রবলেম।
একদম ছটফট করছে,
লেকচার বোঝা গেছে তো?
আমরা তো বুঝতে পেরেছি। So thank you, Professor Povitra Bodik, sir, for very lucidly explaining the importance of remote sensing in identifying our natural resources, and particularly with special reference to agriculture. And also with the help of artificial intelligence, we can minimize the use of weedicides. So today, sir, it was a very relevant topic for us, and thank you, sir, for sharing your expertise with us. Now, with this very beautiful explanation on application of remote sensing and artificial intelligence for managing our natural resources, we would move towards our further lectures. So again, please give a huge round of applause for Professor Bonik, sir, for explaining to us in a very detailed manner the use of remote sensing and artificial intelligence, particularly with reference to agriculture. Now it is time for our next lead lecture, and it's a privilege for me to introduce this person. Our next lead lecture is by Professor Ramkrishna Maiti, sir. I will give a very brief introduction about him, and then our principal, sir, will felicitate him. Dr. Ramkrishna Maiti, a distinguished professor of Vidyasagar University, specializes in advanced geomorphology, is renowned for his extensive research in geographical philosophy. As a prolific author and editor, he has contributed significantly to the field, covering diverse topics from sedimentation in rivers to modern approaches in fluvial geomorphology. His expertise extends to memberships in prestigious societies, including the Geographical Society of India, Indian Society of Remote Sensing, Indian Association of Hydrologists, and others. Dr. Maiti's impactful work reflects a commitment to scientific exploration and environmental stewardship. So, our principal, sir, is now felicitating Professor Ramkrishna Maiti, sir, and it's an honor and privilege for us that we are standing here and he has agreed to share his expertise and knowledge with us.
Respected Principal, sir, reputed scientists from various institutes of India, and my colleagues from different institutes, my colleagues from this institute, research scholars, my dear students, ladies and gentlemen. I like to organizers for selecting such a relevant topic. Actually, we are in a stage of resource scarcity. If I can remember, the 2015 slogan of World Environment Day, I think you will remember that. 7 billion dreams, single earth, consume with care. Presently, we are more than 788 billion people, and we are collecting all of our resources from the single earth. That's why natural resources are in huge stress, and we are to be careful in using those resources, and we are to be very much careful and intelligent for their judicial management. And in my present lecture, I like to put stress on water resource. Do you know how much water do you require per day per person? It is 3,800 liters per day per person, and it is the global average. If we take the example of the developed nations, it is far more. It is far more. And we Indian, we require 3,000 liters per day per person to run our daily life. Do you know how this calculation comes? What we consume, water requires to produce those. If it is 1 kg of nut, it requires 9,000 liters of water. If it is bovine meat, it requires 15,000 liters of water to produce 1 kg of beef. If it is say chicken, then it is 4,000 liters per kg. So in this way, our total water requirement is calculated, and this is called the water footprint. Okay? So this is huge water we require to run our daily life. And at the same time, you have to understand what are the constraints, what are the challenges to get the water on the earth's surface. Water is not easily available, water is not very abundant. And what are those constraints? Number one, potable water, that is the fresh water that we require, is very limited in earth. Only 2.5% of the total water resource is potable water, and of it, 68.6% is arrested in the pole in the form of polar ice, and 30% is arrested in the groundwater, which are away from our reach, common reach. So very limited amount of water is usable. So that is number one constraint of water availability. And one is the unequal distribution. This limited water is not equally distributed throughout the world. Somewhere it is much, somewhere it is much less. So this is another constraint for the hydrologists, policymakers, and water managers to make it available for us. The third and most important one is unequal distribution in time. Nearly 85% of the annual rainfall in India concentrates in the monsoon months only. But we require water throughout the year. So how to make water available for us when there is no rain? There is no rain for last 3 to 4 months, but water is required. So how to make water available for us during that time? So that is another constraint for water management. Even from year to year, annual total rainfall also varies. So that variation of rainfall is another constraint. Now, the most important constraint that a geographer, a geospatial scientist has to remember, has to understand that in spite of having equal rain, water availability is not equal. So it is a very small water basin, nearly half of the size of this room, where everywhere similar rain is received. But if you live here, only this much water is available for you, and if you live here, this water is available for you. That means location within a river basin is most important factor, water availability. That availability is not dependent on the rainfall only. Topography, position within the river basin are more important factors. That has to be remembered. Then water is a very dynamic resource. Residence time, we know the water cycle. Then residence time in any reserve pool, maybe atmosphere, maybe hydrosphere, maybe lithosphere, is very less. The water drop which is evaporating today, which is entering into the atmosphere, has average residence time of only 8.2 days. That means storing of water in a particular reserve pool is very difficult. Water is very dynamic. So it is another constraint. Now the last constraint is what we are facing today is the global climate change. Climate change is another important constraint and which makes water as a more scarce resource. Let's see how it happens. And you know, during the last 3 decades, 1983 to 2012, this is the warmest decades of past 1,400 years. So Earth is warming in such a dramatic rate. And what is the result? The first result comes as the water scarcity. According to IPCC prediction and measurements, that 2/3 of world population is living with acute water scarcity at present. Rainfall is decreasing in larger part of the world. In last 110 years, the brown areas are receiving less rainfall, and if we take the recent past example, in last 60 years, then this trend is more prominent. That means we are having very less rainfall in larger part of the world. How it happens? With the geographers, we know it better that the rain is controlled by here in the equatorial areas, moisture rises and then this get into northern and southern parts, and then it descends being cooler in the subtropical areas. When water comes down, when air mass comes down, water holding capacity increases, so there is no cloud and there is no rain. So most of the dry areas of the world are situated in these subtropical high pressure zones where air mass descends. Okay, so this is the main principle. And what it happens during global climate change or global warming, what happens? Previously this rising air mass descent, because used to descend here, this northern limb and southern limb descends here, and these were the dry areas. These were the previously dry areas, and all as the atmosphere becomes, they are not descending now here. More to the north, more to the south, down. That means they are descending over here. So these are the new areas which are coming as a drier region. These are the new areas which are coming as the drier region in both hemispheres, north and south hemisphere. Then what happens? These are the areas, large areas of the North Hemisphere and South Hemisphere, which are suffering from water scarcity and frequent droughts. These are the areas of Africa, Australia, China, Soviet Union, USA, South America, United Kingdom. They are having recent droughts, very recent droughts. And I am citing the example of very recent drought in Kenya. You see the picture, what happens here. Still, Kenya is demanding for international relief to get rid of this problem of drought. There is no food now. There is no water now. Even today, this effect of that drought is continuing. Drought in other parts of the world, in Cyprus. What is the location of Cyprus? Within the Mediterranean Sea. Can you imagine? Within the Mediterranean Sea, a small island suffering from water scarcity for last 30 to 40 years. Since 1970, this water scarcity started. China, South Africa, they are also having the problem of this water scarcity. Now what about India? Are we in a good position? No, not at all. Per capita availability of water reduces by 272 cubic meter during 2001 to 2011 due to population rise, due to rise in population. But in one hand, water availability is reducing. In the other hand, water demand is increasing. How? At present, for the purpose of drinking, irrigation, drinking, industry, energy and other purposes, as a whole, we require 813 billion cubic meter of water, and that may rise to almost double, 1447 billion cubic meter in 2050. So in one hand, water availability is reducing, in the other hand, water demand is rising. So this gap is increasing much day by day. So this is the challenge of the water managers, hydrologists, geographers, policymakers, how to minimize this gap. Here lies the importance of geospatial technology and the new technology that we are using today. Again, there is another problem of El Nino. I am not going into the details. El Nino frequencies are increasing day by very recently, and as a result of El Nino, there are the say history of destroying entire civilization of Peruvian Moche civilization was destroyed as a result of El Nino event. Then French Revolution was triggered by El Nino event. So lots of impacts were recorded. Those are the historical records, historical impacts of El Nino. And what IPCC is still predicting, that El Nino will be a dominant mode of climate variability in 21st century. Okay? So with all this variability and with all these constraints, it is the present situation of India. 54% of India is suffering from acute water scarcity. And I am citing one example of very recent drought in Marathwada province in Maharashtra. You see that these two pictures are telling everything. What is the level of water scarcity and what is the level of competition to get a particular drop of water during this Marathwada drought in 2016. And during that time, not only Maharashtra, Tamil Nadu, Gujarat, they suffered from this acute water scarcity. And Supreme Court made a memorandum to government of India made a memorandum to Supreme Court that during that time, huge number of population was affected by water scarcity. Tamil Nadu is also facing water scarcity nowadays. And this is the situation in Tamil Nadu now. What IMD is suggesting, that frequency of drought in India is also increasing. Now, what is the water budget? How we can go for the management of this water? We have to prepare very efficient water budget, seasonal water budget. Sir was telling about the agriculture. for every sowing season and every, say growth season, what amount of water is available for us. That budgeting are to be known to us, and accordingly we will go for cropping plan. And here lies the importance of geospatial technique. We can go for SWOT, we can go for HP, we can go for ANN, we can go for decision making trees. With SWOT, we had one work on entire Ganga river basin, how much water is available in Ganga river basin. This is the trend, negative trend. You see these colors, these colors, these area, entire area of Ganga river basin is showing the negative annual trend of rainfall. This is the lean season trend. Almost everywhere we are having negative trend for the last 100 years. Monsoon also, but post-monsoon trend is some positive one, because there is a shift of rain from pre-monsoon to post-monsoon season. But that time water is not required for us. That water is excess, but we couldn't store that amount. So this is a challenge. So these are the inputs: relief, land use, soil group, and climate. So these are the output of annual outflow from 20 sub-watersheds, and these will be helpful. This can be done for various seasons also, and these were done actually for the various seasons, but it is the annual outflow I am showing you here, and this is the water budget. Month-wise, precipitation, snowfall, potential evapotranspiration, evaporation, soil water, percolation, groundwater and surface flow. The total could be done for each and every sub-watersheds, and accordingly you can plan which one is the deficit season, which one is the surplus and how much surplus is there, and at what percentage of that surplus you can use. Okay. So the water management plan could be easy if this information is available for the planners. Then you can go for ANN also. Various inputs are to be prepared very carefully. If there is any mistake in preparing this input and the inventory map, then your output will be different and erroneous. So be careful for preparing these inputs. These are various inputs, and all those inputs are put here, and it is the work of the artificial intelligence. They make these connections and interconnections which are beyond our manual capacity. Machine does this, and ultimately they produce your output. And there are lots of algorithms to prove whether this output is true or not. Then another prediction model is decision trees. Here their interactions are very easy to understand. You can manipulate those. You can increase the number of trees. You can put add the inputs. So lots of things you can do, and ultimately these will be the products. Okay. Now we can conclude here that freshwater resource is not sufficient. It is becoming scarce day by day as the gap between demand and supply is sharpening, and in the context of global climate change, this will be sharpened in future also. Now it is the time for effective water management, and we have to prepare basin-specific water budget. And for preparing those water budget, the geospatial technique is very important. It is an effective tool. We can go for SWOT, we can go for artificial neural network, or we can go for decision trees. Thank you very much. Any question?
Shall I ask, sir?
Yeah, please, ma'am.
So it was a wonderful lecture. First of all, I thank you for this lecture of very most important topic. Sir, I wanted to know that when we are constructing dams for the water supply in the drought time, do you think there is a change in the river basin morphology because of the construction, and what is its future implications on the natural resource of that particular area?
Yes, it's a very important question. Madam Banerjee, Dr. Banerjee has asked me. If we construct large dam to store huge volume of water, then what is its impact? Actually, those who have the basic understanding in river geomorphology, they know that previously, without having the dam, the river carries its water and sediment from source to mouth. The base level was at the ocean or at the main river where it meets. But whenever you constructed a dam, base level has been shifted there. Yeah. So entire gradient, river gradient and graded condition has been changed. So the upper course of the river is automatically becomes erosion prone, and it produces more sediment now, and all those sediments are transferred into the dam, and dam has to carry all those sediment load, and within few decades its water holding capacity is lost. Okay, and surrounding areas are also becoming more erosion prone due to this loss of graded conditions. Okay, so in say Damodar river basins, all the dams, they have lost their carrying capacity ranging from 30 to 45%. Tilaiya dam has lost its 45% of water holding capacity, and it is the concern of United Nations now, because that more than 10,000 dams in the world, they crossed their lifespan of 100 years. They are not at all effective nowadays. So how to remove those dams? America has started their policy of decommissioning of the dams. During 2010 to 2020, they destroyed more than 5,000 dams in their territory. But they have the different setup. Impacts are not so heavy on their territory. But if we deconstruct that dam or if we destroy the dams, then the entire lower catchment will be covered with the sediment load. Society, agricultural fields, everything will be destroyed. So it is a much more concern of the government as well as hydrologists and the river scientists nowadays. What to do with those age-old dams? Thank you, ma'am. Any other question from student side? Okay, thank you to the organizers for calling me and to share this fantastic gathering and to share my own feelings with you. Thank you very much once again.
Thank you, sir, for elaborately explaining about the situation of water scarcity in our state and how with the help of geospatial technology we can manage those water resources. So thank you again, sir, for presenting your lecture and sharing your valuable time as well as knowledge with us. So now we will move on for the lunch break. After the lunch break, we will have 2 lectures by Dr. Kakuli Banerjee and also by Professor Nilanjana Das Chatterjee ma'am. So now we will move on to the lunch break, and I would now like to request our esteemed guests to kindly take their lunch, and our participants, you all are also requested to go to the canteen for taking your lunch. Thank you again. We will meet again after the lunch break at 2 p.m.